When someone mentions the term air pollution, you probably imagine a factory emitting thick black smoke into the air. While this isn't necessarily incorrect, most air pollution actually looks quite different. In fact, we often can't even see it. Two textbook examples of air pollution are CFCs and the combination of nitrous oxide and sulfur dioxide. CFCs used to be widely used for coolants and aerosol cans, but these molecules also broke down the ozone layer that protects us from harmful UV radiation. Nitrous oxide and sulfur dioxide are byproducts of burning fossil fuels. These compounds mixed with precipitation to create acid rain that harmed ecosystems. Today, the hole in the ozone layer is shrinking, and acid rain has been significantly reduced because of aggressive government actions. However, even as we are fixing these problems, a different form of air pollution has quickly become much more dangerous: carbon dioxide. CO2 is a naturally occurring atmospheric gas that is necessary for all life on Earth because it supplies carbon atoms to living organisms while helping to moderate the Earth's temperature. So how can this life-giving, life-preserving gas be a pollutant? The same way that anything becomes a pollutant. When the concentration of a substance increases to the extent that it begins to disrupt natural ecosystem processes, it becomes a pollutant. This is precisely what is happening in the Earth's atmosphere today. CO2 has steadily increased each year for almost 200 years. This is concerning because CO2 is a heat-retaining gas. The greater the levels of CO2 in the atmosphere, the more heat that is retained. CO2 has an uneven molecular charge which causes it to reflect heat radiation back to the Earth's surface, just like a warm sweater reflects heat back to your body. The more CO2 in the atmosphere, the more heat that is reflected back to the Earth, and the warmer the Earth gets. So where is all this CO2 coming from? Well, CO2 is formed from the atoms in organic carbon-based molecules anytime those molecules are burned, respired, or decomposed. The only way to remove CO2 from the atmosphere is by photosynthesis. The amount of photosynthesis used to be roughly the same as the amount of cellular respiration, decomposition, and burning. However, more CO2 accumulates in the atmosphere each year because those rates of burning, decomposition, and respiration have increased as a result of human activity. This annual increase in CO2 causes more heat to be retained each year. This is especially concerning because increased heat retention changes precipitation patterns around the world. Heat is a form of energy, and an atmosphere with more energy can hold on to more precipitation for longer periods of time. This increases the frequency of severe droughts and major flooding. As a result, our abilities to produce sufficient amounts of food through agriculture will continue to become more and more difficult as flooding and droughts become more and more common. Unless we can decrease rates of burning, decomposition, and respiration, we will continue to increase the amount of atmospheric heat that is retained while increasing the frequency of droughts and flooding.